Okay, what's up? Welcome back to the channel. This is the Prokon Geek, and in today's video we're gonna be designing it's actually the first floor columns of our double story building. So without wasting too much time, let's just get right into it as we cruise to some music. Okay, but before we actually begin the design, please, if this is your first time, just go up to my channel and click the subscribe button, then like the video. Also remember to leave a comment if you're enjoying my content, and also if you have any feedback, just leave a comment in the comment box below. But please do like the video, as this is the only way other people get to see this video. So leave those likes and let's get cracking. Okay, now that we're done with the subscription part, the first thing we want to do is design our first floor columns. Now, if you remember, we have been designing every element of our building, and the first thing we did is we started with the foundation, then we moved to the ground floor columns, then we did the beams, and then later on in the very previous video we did the slab in sumo. So now the next thing that we want to do is design the columns, as you can see on the screen, for the next floor, which is the first floor. Which is actually the first floor. So what we're doing is we're designing for the 3000mm part now, and if you can get a better representation, let's go to where I did this, where I showed you. So when we did the first part of the columns, we did for the 5125mm section all the way up to just above the slab where you have the lap. Now what we need to do is to design for the 2375mm portion, which is 2.3 meters by the way. So this is the portion that we now want to design, and the difference in designing between this portion and now the 5125 portion is that the loads are different. With the first portion, we had the loads coming from the column itself, then the loads coming from the beams, and then the loads coming from the first floor slab. But now when we go to the 2.375 meter section, we only have the loads of the column, none of the slab, and just of the eaves beam. So that is what we now need to do. So let's design these babies and see how we can do it. Okay, so the first step that we need to do is we need to go to our Prokon, then obviously you know by now, go to rectangular column. Well, I already had it open, and I think you remember all our columns are 300 by 230, nothing has changed. So we did this in the very first video, so please go back to that video if you need to know where 300 and 230 came from. Now for the DX, and you know it's 48 and it's 48. If you remember, it was 30 plus 10 plus the bar, which was an 8, 16, so we went with 30 plus 10 plus half of 16, which is 8. That was 48. That's how we came to 48. Now for LO, what we need to do for this ones in particular, it's going to be 2.375 up to the eaves beam. But what we're gonna do is, if you remember from the section, what we had is we had a 3-meter portion, right? So this is actually the most accurate drawing that we had. I think I missed a few pointers, but from our section, which is the drawing that actually guides us, this one was just more of representation so that you guys would not be able to miss it. So what we're gonna do is, and the fact is, this 2.375 doesn't take into account this lap as well, so we need to take that into account. So if we add 2.375 plus the lap that we have, which is probably 750, I'm not too sure about the mathematics, but it gives us 3 meters. You can do the math, please don't pee me on that. So what we're going to do is we are going to put 3 meters, because that is what we need to design. Then the FCU for the columns, if you still remember, just go to the drawing. If you just go to the notes, with the music just playing around. So if you go to the columns, the strength that we need is 40 MPa, so that is why we put 40. And then for the steel, we use 460. Then please, before we proceed, just make sure that you're using the design code. You're gonna go with SABS, press OK, then also save as, because now we're designing the first floor columns. So this is I'm in the right folder, right? Yes, I am in the right folder. First floor columns, we're gonna call this column 1, because we're gonna be designing column 1. So we're gonna save it as column 1, and then we're gonna tick braced and braced. Then we're gonna change to pinned, and then we're gonna go with pinned as well. If you want to know the reason behind this, please check out my other video. I explained everything. So we're just doing the same principles and we're carrying them to the first floor as well. Then the load case 1, this is where we stop, not stop as such, but now we need to move to step 2. So this was step 1, entering the parameters. The next thing we need to do is go to step 2, figuring out the loads. Okay, figuring out the loads is quite easy. All you need to do is go to your takedowns. Now, some of you may be wondering which one is column 1. If you're new to this video, please go to the other videos. But if you're new, I'm just going to show you which one is column 1. So where are my shells? Column 1 was our hard hit column, the ones that are in red. There are 3 columns, so we just need to design them as well. So column 1, what were the loads? All you have to do is go to your takedowns. I think I've shared this with some of you, but if I haven't shared with you, just get in touch with me. So for column 1, this was for the overall design, going all the way to the foundation. But now when we get to the first floor, we need to ensure that we remove the slab. As you can see, at the first floor, you don't have the slab. All you have are the eaves beams and the first part of your column. So to design this column, you still have the roof, so you're good to go. Do you have any slabs? You don't have any slabs, so you put 0. Okay, you're good. Then, do you have any walls on the slabs? No, you don't, so you put 0 as well. Then for the beams, how many beams are left? You don't have the 2 beams, you now only have 1 because it's the eaves part. And now the walls on your beams, no, you don't have any walls on your beams because they are on the eaves beams are just supporting the roof, and you already have the load for the roof, so you're good to go. Then the columns, you now only have 1 portion. You no longer have the stub as well, so you get down to 0. So now you have 1 0 0 1 0 1 1. Okay, that is no, you don't have any walls on the beams as well, so take that off. Now you're down, so you see this is the load that is going to be carried by the second portion. Now, so you see this is the dead portion, this is the live portion, this is the total, and then the total factored load is going to be 98.813. This is for column 1, right? Wow, this is very low, man. So this is what you're going to do. You're going to say DL plus LL. Once you do that, then you come back. Now you're looking at column 1, the total load is 98.813. So you're going to put 98.813 and nothing else. We don't have any moments. We discussed about this in the very first video. So please refer to that video and then you come back before you watch this one. Now all you have to do is say design, and I am looking at the results. The results seem to be good. And the design charts now, the results are good. There's nothing that is in red. We talked about how to interpret all of these results, so now let's just click next. We don't have anything that's bad for us. So design charts, I talked about these ones as well. Calculation sheets, don't have to worry about this. This is just the history. Last but not least, what you need to do is check your bending schedule. So this one is telling me 16s are okay, but I can try and play around. We'll see if I can have 12s in there. So if I put 12s, I am good to go. So at the top we need 12s, at the bottom we were using 16s, so we're good to go with using 12s. And this is okay because the minimum bar in a column is supposed to be a 12. I'm sure about that. So with the 12s we're good. So the next thing that we're gonna do to make sure that we have the bending schedule, we're just gonna call this first flow call 1, so that it's generated. If you want, is it a continuous column? No, it's not going to be a continuous column. It's going to band off at the top, so you change that. As for the links, we are okay. The level at the top, we are okay. Cover on the links, we are okay. Left length factor, we are okay. First bar mark, just change that to 1. You're okay. Is there anything that we need to change as well? No, we're good. No double kinks. So this is how it is going to look like. So once you've done this, you're done. You've designed column 1. Next thing, we just need to design 2, 3, and 4. So these are the first floor columns. So once you do that, save it, generate your schedule, and then click OK. All right. There you go. Click OK. And now we're done. Let's move on to 2, 3, and 4. Okay, now we need to move to column 2, 3, and 4. The next thing that you want to do is go back to file, click file, save as. This is now column 2, so you're going to create this column 2. Save as that, go back to the input. So everything is still the same. I explained this as well, but because the geometry is still the same, cover is still the same, length is still the same, FCU is still the same, still the same conditions, brace throughout. We talked about bracing. Now the next thing that we need to do is take care of the load. Now, so what we do is we go to the takedown where we have 2. Let's just save this one. But yeah, let's save this. No, we don't want to save this one. Let's just save. Let's go to 2. We'll save it as a different name. So when it comes to 2, we no longer have the slab, so we're going to put 0 there. For the beams, we now only have 1 portion, so we're going to put 1. Then walls on beams, you don't have these anymore. The columns, you now have 1. Then the stub, you now have 0. So this is it. The total load comes down to 78.120. That is what you take. So you're going to come here and say 78.120. Okay, you're good to go. Next thing, you want to put design. Check if there's anything that's in red. You don't have anything that's in red. You're good. Design charts, calculation sheets. Then look at the bandage schedule, still saying 16s. Let me put 12s. 12s are still okay, nothing is in red. As you can see, the entered still is more than the required still. Entered still in the Y as well is more than the required still in the Y. So once you do this, you're good to go. Next thing you want to do is just say FFL column 2. Once you do this, it's not a continuous column, that's okay. Next thing you want to do is everything okay? The spacing of the links is okay. Cover on the links is okay. Length factor is okay. First bar mark, maybe you want to change this to 1. Everything else seems okay, so generate the schedule. And voila, you're good to go. Alright, so go back. Once this is done, close this. And this time you want to go with column 3. So you're going to go like this. Click save. Go back to input. This is the beauty of doing the things which are the same throughout. You're doing a rectangular build and it's just the same, man. It's so easy. So this time is what you're gonna do is column 3. So once you're doing this, go down to the takedowns, remove the slab, put this 1. So walls and beams, you don't have these ones anymore, so you have 1. And you don't have a stop anymore, so it's 33.960. okay, so at this point in time, what you've seen is the minimum bar we can use in a column is a 12, right? And the issue is, as you can see, our loads keep getting smaller and smaller, but we have designed for bigger columns which have bigger loads, and using 12s is okay. So this is when detailing comes into hand. Now if we continue doing this, it becomes redundant. We're just doing the same thing. So sometimes when you start seeing things like this is when you say, okay, so I've designed for like the worst case scenario, which is column 1, and the minimum bar is a 12, and basically it was able to take a 12, right? If it's taking 98 and it needs a 12, what about a column that's taking 33? It's common sense. If we just click it up and we go to the banding schedule, look at this. We're just gonna FF column 3, and if I put 12, just check. As you can see, you know, it's common sense. Now all you need to do is just know that all your second floor columns need 12s. I'm just gonna save this because we have been doing it and we did it, but I'm just gonna save this. Click OK. But now I think, you know, we don't really need to design the 4th column. It's like the list column of this, but this is what I wanted to show you. It's like the most important thing is when you design it for the ground floors, but when you go to the top, it's easy. You can just rush through this. But let me save this, and then we talk about the next step in the next video. Not in the next video, in the next section. Sorry about that. Let's just click. Okay, it could not be generated. You know the error that we encountered in the previous video. I need to change the name as well. Let me just change the name to FF column 3B, generate the schedule. Alright. Okay, that's good. We've changed this. So once that is done, the schedule has been generated. This is okay. We're not going to design column 4. We've already talked about it. Next, we need to see what are the next steps. Okay, so like I told you, as you can see, it becomes redundant to keep designing some of the things. This is when you just use your common sense, use your mind, and use your engine. So this is why I'm saying it's quite important as well to use your brain when you're designing these things. You know, the detailing codes. So when you're designing, you need to fetch from a number or a list of things before you come up with the final thing. So that's the thing. But the most important thing that I want to tell you is I just wanted to show you the important thing about designing the second floor columns. I wanted to show you the change in laws that happens, and also now you can see the most important part when you design your columns is usually the one that is just immediate or that is connecting to your foundation. That will usually has the largest steel. Then the ones that go on to top, or when you're now going to the second, third, fourth, fifth column, those columns will really definitely need less steel than the ones that connect to the foundation. That is the most important thing that I wanted to show you with this video. But now, since what we did, let's go back to AutoCAD. So as you can see, we have designed every element, the foundation, the columns, the slab, the beams. Now there's going to be the eaves beam. So normally what they do, eaves beams, normally as you can see, it's 200 deep eaves beam. People will be looking at the type of roof, and even this roof can be easily designed by a carpenter. By design, I mean carpenters really don't even need engineers' drawings when they're doing these roofs. But what we will do is we are going to do the eaves beam. right? And then we're also going to do the roof. But what I need to do right now is that we now need to start detailing the other components or the shell of the building, because the eaves beam and the roof, in as much as they provide loads and they're part of the building, they are not the integral parts of this building. So what we now need to do is we now need to go to the detailing of the foundations, columns, ground floor slab, first floor beams, first floor slab, and all the way to the first floor columns. Once we have this detailed, we can produce the drawings, send them out. Then the next thing that we will do is we'll do the eaves beam and the roof. So the important thing that why I need to do this roof is that it is designed using frame, which is this funny figure analysis frame. So it's a good thing. Normally I don't have to design such a small roof, but the good thing is once we design it using frame, you will be able to understand how truss design is also done in frame and how to detail these roofs. So please bear with me. I want to teach you everything, but I want to make the transition nice and good. So what we want to do is to make sure that, yes, we don't want to dwell too much on the design, the mathematics. We also need to do the detailing so that it's like a crash course. We're getting everything in the shortest amount of time possible. So yes, open GL mode. So this is frame, this is where you design model. So as you can see, the interface is a bit different from all the other interfaces we have been using. So this is the reason why I want to design that roof in frame, so that you guys get an understanding of how to do it. So this is it, ladies and gentlemen. Now we're moving on to detailing each and every component. We're going to start with the foundations, then we move to the columns, then we're going to do the slabs, which is that is where most people have a trouble or have a challenge. They don't know how to place their steel. So that is where we're now going to. So hope you enjoy the music, hope you enjoy the video. Please, if you're new to the channel, subscribe, click the like button, and also leave a comment behind so that we get to know what you guys like and what you don't like. So if this video was a bit rushed, it wasn't really rushed. It was good for you so that we cover everything in the shortest amount of time as possible. And keep up to the bit, enjoy the music, stay safe.